Yes, hello. So I'm going to finish chapter or section 10.4 where we're going to multiply. So in 10.4 at the beginning we added and subtracted, and now we're going to multiply radicals. So I wanted to work the one on the right, I think. So, or I'm going to save that one for class. So this is what I was going to do. Work the left one. Okay, so here's one thing you cannot do. This is where you have to remember the rule that a minus b quantity squared is never a squared minus b squared. Because what if you foiled? Isn't it? It times itself by definition. Exponent is the number of times my base is a factor. My base happens to be a binomial. And then you would FOIL it, and that will always give you the middle term. We've done this before several times, chapter 5 and then chapter 6. A squared minus AB minus another BA, which AB is a BA, so minus 2AB. Negative B times negative B is positive B squared. And this is that formula you could use to go straight from here to there. So we could do this by formula, but I'm going to go ahead and FOIL it because most of you do better with the FOIL. But just remember, if you like formula, you can totally go for a formula. But even with the radicals now, it gets a little more dangerous. So I rewrite it, and then I multiply first times the first is the square root of 3 squared. Outer first times the one over here, the most outer, is square root of 3 times negative, so it's positive times a negative, and then square root of 3 times square root of 7 is the square root of 21, because the nth root of a times the nth root of b, if the index is the same, you can go under to multiply. You gotta be careful this doesn't apply to adding. So we're gonna go under and say 3 times 7 is 21. Then we have the inner negative square root of 7 times square root of 3 is square root of 21. And then we have the last, negative times negative is positive. Square root of 7 times square root of 7 is square root of 7 squared, and you guys might go ahead and make that a 49. But I'm going to leave it like this, and then I just bring out the 3, because that's back to the basic nth root of a to the n is a comes out, yes? And then I have these are like terms. Minus 1 square root of 21 minus another square root of 21 is minus 2 square root of 21, because this is like saying borrow $1, and you owe $2, and then you have a plus, and then the 7 would come out, and then you could combine these two here. See, 3 plus 7 is 10. 10 minus 2 square root of 21, and that would be your final answer. Now, why do you need to know this? If you have a really good calculator, it might do all this for you. However, you see how here I put an xn there. That's most likely what you'll see more in an exam, because I want to make sure you can do the work. So if there's an xn there, then you cannot just use a calculator. So now we're going to move on because we have a lot of work to do. Oh, I can't get this to work. Okay. I have several of the very similar. So I want to be efficient, but might not work every single one of these. Okay, what is this? Multiply and then simplify if possible. What we're doing right now is we're always assuming that any variables represent positive real numbers, or you would end up with possibly having to deal with absolute values. Square root of 14 times y times square root of 14. This is like, you could take the 14 times 14, find the 14y times 14. Do you see that that would then be 14 times 14? And you know, I don't care what number that is. I'm going to write it like this because that's what I want. So this is going to be square root of 14 squared y, and then minus square root, and then the 14 only appears once, but the y times y makes a y squared. See, this, you just have to be careful here. It's a little tedious. Which one of those has an exponent that matches the index? Technically, the index here is a 2, so what comes out, 14, what stays under the y? In this case, what comes out, you see, this is where people get a little confused on, they look so similar, but they're not the same. Which one has the exponent that matches the index, the y? And then you can't say they're like terms because they're not. So you just, this is the end of the story, okay? Okay, and then I might not do them all, but we'll see what this looks like. Which one of these do I want? I guess I'll just work the one, this one here first. 4 times 3 is 12. That's on the outside of the radical. Square root of x times square root of x is square root of x squared. Outer. 4 times negative 4 is negative 16. There's a square root of x there. Inner. Negative 9 times 3 is negative 27. And square root of x. Last, negative 9 times negative 4, positive 36. Now, this one here, the first one, the x comes out. These two, I could combine. I borrow $16, I borrow $27. I owe $20, $30, $43. I hope. And it's still dollars. Okay, and then you have a plus 36. And then in this case, these two don't combine, or there's nothing else that's going to happen. None of them are like terms. Now, in this one on the right, actually, I'm going to skip that because there's one very similar one coming up. I did these ones on the right. These are extras for when we hold class and you look at them. Oh yeah, see, and I used, right now I'm using the drawing tool, which scrolls down nicely, but it does not delete. I have to erase the whole thing by hand. This one here, it's not anything special, so I'm going to let you work this one. But this one here might turn out a little bit interesting. I'm going to go ahead and use the annotating again because I would rather have this. Okay, FOIL. This is actually a minus b times a plus b. If you notice that, is a squared minus b squared, right? So you could use that formula from back when, but I'm going to go ahead and FOIL it because most of you FOIL first. Outer. Now you have to be very careful. I would always try to put the j, the one without the radical first, so you don't, it doesn't end up looking like it's under. Minus j square root of g. Negative times positive is negative. J times j is j squared. There's no radical on this one, so you gotta be careful. These two combine, so they're gone. And then this g comes out. You see, one has a square and one does not, so be careful with this. Okay. I'm going to get more efficient as I move down. Let me see, is this the end? This is the last one. Okay, that's good. I wanted this to be a little bit shorter because 10-4 at the beginning was already kind of long. Okay, are they exact up, or is one a plus b and one minus b? Nope, they're very similar, but be careful that you can't use the formula in this one. We're going to FOIL. Square root of 6x times square root of 6x is square root of, instead of me saying 36x squared, I'm actually going to say 6 squared x squared. So this is personal preference. Some people know that the square root of 49 is 7. and that the square root of 36 is 6. Other people struggle with that. So why not just say 6 times 6 is 6 squared? Now my exponent matches the index, and then I don't have to worry about it. And then the outer, first outer. So this was first. Now I'm going to do outer. See how there's no coefficient on that first one in front of the radical. So 1 times negative 2 is negative 2 square root of 6 times 5x. Do you see how 6 is just 2 times 3, and there's nothing going to be squared, nothing's going to come out. So you could just call that 6 times 5 is 30. X times x is x squared. It is underneath right now. Okay, inner. Negative 3 square root of, now 5x times 6x is 30x squared. Then you have a negative times a negative is a positive. The 3 and the 2 are on the outside, so they'll get multiplied. And then the square root of 5x times the square root of 5x is square root of 5 squared, x squared. So this is just me doing it my way. You can do it a different way if you like to make that a 25 and then say square root of 25 is 5. Now I'm going to pull the 6 out, the x out. Then I'm going to say, hey, these two are like terms. This is like I borrow $2. I borrow $3. I owe 5. Still dollars, not tomatoes. So don't change what's under the radical on these. This is just combining like terms. Plus, there's a 6 here, times, there's a 5 going to come out, and there's an x going to come out. So you have, and I know I'm doing, you might be able to do some of this all at the same time. I'm doing this, I also have to be careful because I didn't, prepare this so that I could see it just like you would for the first time. Doesn't matter what the order is, 6x plus 30x is 36x, and just be careful. You're not going to have an x squared. 6x, this is like saying 6 apples plus 30 apples is 36 apples. So don't make that an x squared. That only happens when you multiply. Minus, and then this is the way it is. Oops, up. Just a second. I catch my own mistakes. Usually the x comes out, doesn't it? I could have done that earlier. The x comes out, and then I have a square root of 30. And be careful, they look very similar, like very similar terms, but these are not like terms. For them to be like, you have to have all the variables and radicals the same. I'm looking at this for a second. It is possible that in my math lab that they would allow the answer to be like, do you see how we have 2 terms and they both have an x? Everything else is not the same, but they both have an x. You could write it like this. X times 36 is 36x true. X times negative 5 square root of 30, you see this, is technically that one, but I would prefer this over here on the left. That one on the right is in factored form, and nobody asked you to do that right now. So that's it for 10.4, and then I'll make you something new for the next section.